And a very good day to you. It's great to have your company today as we start up another edition of the Blue Files, the extended edition. You know, there's so many intriguing stories that don't seem to get the spotlight that they deserve when it comes to our changing planet, and that's exactly what this web series is all about. My name is Anwar Knight. I'll be your host, and I'm thrilled to welcome back Christina Stevens, our West Coast contributor, to help tell some of those stories. How are you today, Christina?
I'm doing pretty well, Anwar, and I think we have an interesting, diverse group of stories today.
Without question, in fact, we should just get right to it. I want to start with what I would say are really distressing details out of this new research that's coming out of Antarctica. Tell us about it.
Absolutely. Well, it centers around a glacier called Thwaites Glacier, but it's probably better known by its other name, the Doomsday Glacier, and that should tell you something about how serious this is.
Yeah.
Now, picture the far reaches of Antarctica, so far away, only a handful of people have ever even been there. A huge white expanse. This glacier is one of the largest in Antarctica, and the fact is, it's melting. Now, of course, we've known that for some time. The new thing is that a recent excursion found it is actually melting far faster than anyone had previously realized. So picture this. This glacier is about the size of, say, Great Britain or Florida, so that gives you an idea of its size.
Yeah.
And as it melts, it's slowly increasing the sea level. So since the 1980s, for example, 540 billion metric tons of ice has melted, and that's helped contribute to about a 4% rise in global sea levels.
Yeah.
So now what's happened is they've finally taken an unmanned submarine, which has gone in, and it's shown that there's a warm current that they kind of didn't realize was having so much impact. And it's wearing away at basically the underpinnings. You know, if you can picture, it's kind of attached to the sea floor at
Right,
the
yeah.
edges by pins. And it's wearing away at those faster than previously thought. And if those go, the whole thing goes. So the best description I saw is that someone described it kind of like a cork in a wine bottle. So this glacier is kind of holding all the others back, holding everything in place. If
Right.
this one goes, basically all the ice in the region could just flow into the sea.
Yeah.
Altogether, if all of that does, we're talking about something like a 3-meter rise in global sea levels.
Right.
It's interesting too, this unmanned submarine that they were able to use, it not only measured things about the water, like the temperature and the oxygen levels, salinity, it also has sonar, which enabled them to do some high resolution pictures and give them a better idea of what's really going on, and sadly, not a great idea of what's going on.
No, and you know, you mentioned Doomsday. It has, you know, it had that moniker for quite a while. It is the most unstable glacier in Antarctica. So just so as we paint a good picture here, you mentioned the size. It's huge. It's the size of the state of Florida. I mean, this is very, very large. So this little unmanned submarine has gone to the deep depths, and that's what makes this so different. And they've discovered little channels into the deep ocean of little currents of warm water. And they knew some of it existed, but now they're confirming that it's quite a flow. So when you're talking about melting the unpinning, it's literally, I want to say chipping away, but melting away the contact of this gigantic block of ice to the seabed floor. So now we can understand if that's happening and it's starting to lift up, the melting is intensified. And that is, you know, the worst case scenario in all regards. You mentioned it already contributing to the sea level rise. So as I understand it, you mentioned 3 meters. That would be the ultimate catastrophic output in terms of it melts and it's pulling some of the other Arctic shelves, Antarctica ice shelves away with it. So now it's just
Releasing them. Essentially, it's holding
Exactly.
everything in place, just
And away it
kind of
goes.
starts to float away. Yeah.
And
Yeah.
if just in itself, if this starts to melt off, some scientists are just suggesting that the sea level rise just with this block of ice would be over 0.5 meter, about 65 centimeters, and that would have a profound impact for coastal communities around the world. So I guess the question is, you know, and I perhaps know the answer, but is there anything that can be done about this now?
Well, there's the obvious but very slow answer, which is reduce and stop putting CO2 into the atmosphere. I mean, that's part of the equation pretty much every time we're talking
Right.
about anything like this. That's part of the equation. It's probably not going to be enough or fast
No.
enough. It's not going to solve this. So engineers are starting to work on different sort of unique projects, different sort of out of the box ideas of if
Right.
there's some way they can somehow protect these underpinnings. But those are all really in the initial stages, and there's nothing concrete at this point. And it's interesting too, scientists don't even really have a timeline.
Yeah.
They can't say how long. Are we talking, a couple of years, a few years,
Sure.
decades? They don't really have a timeline as to what this could all take. But it's urgent that it gets taken care of in some way.
Well, and it's all part of that the parcel Pandora's box. The urgency is there, and I think it's important to note. Of course, we have to push full steam ahead, 100%. In reducing global greenhouse gas emissions. But it's important to note what efforts are done now is not going to stop what's happening. Like with the Thwaites Glacier,
Exactly.
that's going to happen in some form or another, but it's preventative decades from now so it doesn't get worse. So when we talk about the other ice shelves, to prevent them from being released and melting, and I would imagine the other positive side to this is that now that they have better research data, they can now make new models and maybe remove, at least at the very least, some uncertainty on the way it's operating. So when you say they're trying to look for solutions, they at least have something to go on, no?
Exactly. I mean, that's when I talk about this unmanned or uncrewed sub has sonar. So it can paint a
Yeah.
very detailed picture. Before they were really not guessing, but really sort of
Speculating.
surmising what was
Yeah.
happening down there.
Yeah.
I mean, some of their research involved it's even hard to kind of understand how it helps. They kind of putting a bomb down there, and then when it went off in the water, they would measure the waves and what's happening underneath. So obviously, that's not going to paint a very precise picture versus having this, submarine down there actually being able to measure things specifically.
Well, and I guess there it is. Technology is certainly helping in this regard significantly because, as you mentioned, there's not a lot of people that have been there, let alone research being done there. So that's something we're going to continue to monitor. Thank you for that. From there, we're going to go to one of my favorite countries, Italy. For real, I think this is just a fascinating story, and we're going to discover sustainable living at its finest. It is a clay home that has been made by a 3D printer. It's clay that's been ejected by a printer. You have to take a look at this. It's about 640 square feet. There are certain rooms in these dome homes. So there's a living area in terms of, you can sit and eat. There's a kitchen, and then there's another one, which is a bedroom and a bathroom. And it took 200 hours to print, and it's been done by an Italian architecture firm. And I think it's fascinating. First of all, it's striking to look at the images of the homes. And I don't know, is this something you would maybe want to move into at some point?
I mean, they're beautiful in their own way, but I ask practical things. Like, can you attach a picture to a clay wall? Honestly, I'd have to know that, right? Because you
Yeah.
can't just look at all that clay all the time. I mean,
Functionality.
on the bright side, 640 square feet is a lot bigger than a lot of condos these days, so
True
that's
enough.
something. But how do they? Okay, I kind of picture, when you're a kid doing like little clay projects and stuff, and then you're done, and then it cracks and falls apart, or at least
Right.
mine did. Does it wouldn't crack and fall apart with the weather, or I don't know,
Well,
anything cooking on the inside, that kind of thing?
it's a
Well,
good
really,
it's a good
anything
question.
too.
No, it's a great question. Now it does have a kitchen in there, and everything is molded. A couple of things here. So, firstly, structurally, the concept of the dome. I mean, that dates back centuries. Just the premise of how it's built. It distributes the weight evenly. There's no one particular spot that's taking more weight than others. So that has been tested. They are confident so far that they want to now advance this into a two-story structure. But I think it's important to note they don't think it's going to be a solution in mega cities, in a metropolis. This would be more geared towards low-income nations. And the fact that you're able now to create a dwelling out of the local resources. So eco-friendly for starters, you're just removing the concept of concrete or cement, which is a huge carbon footprint to manufacture cement or concrete. So there's that. Two, machines and supplies. You don't need a lot of trucks, a lot of things coming to the site. It's just the 3D printer. And they use the local soil. So, firstly, they would sift it through. They get rid of the stones and the gravel. They mix it with water and then add, which I found really interesting, rice husks. And that helps make a paste that goes into this 3D printer. And they literally will start building the walls with an ejection printer system. So, in some regard, that concept has been tested as well in many countries around the world through the beginning of time. Will it withstand a hurricane? Well, I don't know. There's not a lot of structures that will, but I think it's a step in the right direction in terms of thinking outside of the box, especially if you look at some third world countries where housing is very limited in terms of what they have. This concept could be a step above, and it's eco-friendly.
And I mean, when you say they built this in 200 hours, on a 3D printer, that's not very much. Like, to me, that's really
No,
quick.
sure.
How can you build, a 600
In a
plus
week.
square foot home in 200 hours? I mean,
Yeah.
that's actually pretty phenomenal. And also, I'm guessing using the natural materials, that kind of thing, it would be good insulation. There's a lot of really hot, like the desert parts of Australia, that where you see they can dig homes kind of into the cliffs,
Sure.
into the dirt. So I'd imagine with this, the walls would have to be somewhat thick, and it would be a natural kind of insulator if it's really hot or really cold out to keep
I
it.
think you're right. Yes, I think you're absolutely right. And again, they said that they would have to adapt it for, the area that they're in. They'd have to look at the soil and figure out the best recipe, if you will. But, one thing that I was really quite impressed, it's just the 3D technology in itself. You may be surprised when I tell you it's been around for 40 years. Although not widely, accessible, it was, really elite initially. But now, everything from toys to tools to airplane parts to even human body parts are being
I was
made.
just going to say prosthetics are being made, which I
Yeah,
think is just
it's amazing.
phenomenal.
It is.
Yeah.
It is amazing. I was reading one article. They're doing antibacterial teeth. So they are 3D printed and they will resist bacteria just with the stuff that they put in it, which I find fascinating. So that
Yeah.
is one example. But there have been other 3D projects in the US, but they use concrete. So not equally eco-friendly in that regard.
Okay.
But one, expert was suggesting that it may be actually the wave of the future, 10 to 20 years from now, solely based on the reason of labor shortages. So now they can, and again, this would be using concrete, but they can sell a plan for a home. As a purchaser, you see, I need a 2 or 3 bedroom model, and they would 3D print it right on site using concrete. So the technology is there. I think this will only get perfected by this Italian firm in particular, because at its core, they want it to be sustainable. And that's what I loved about it. And I just think some of the images and the
They're
concept of how
beautiful.
they've done it. Yeah,
It kind
it
of,
really is.
beehive kind of, I love that because it's
Yeah.
part of the environment, working within the environment.
Yeah.
Yeah.
So I guess it's just a matter of, really promoting it as, this is the wave. You're going to be the cool home on the block. You live in that. And it's dubbed by the way, Tekla. So technology in clay is how they phrased it. But anyway, I thought it was fascinating. Let's get to our last story. It reveals another ally now in the fight against plastic pollution. And look, we need as much help as we can get. Take us aboard what is called the Manta.
Well, the Sea Cleaners, the group behind the Manta, they really kind of describe this as a plastic gobbling sailboat. Sail yacht, perhaps,
Right.
sail ship. It's huge. So it's
Huge.
a one of a kind ship that's designed to actually collect, all that plastic that's floating out there in the ocean. It collects it, brings it on board, treats it, sorts it, does the whole thing. And they're going to focus on really highly polluted waters, which tend to be at the mouth of rivers. It's interesting. I always think people think, oh, all the litter in the water, it just comes from people along the water's edge or whatever. It comes down the rivers. It comes down the rivers. So this Manta,
Number one source.
yeah, this Manta can collect all of these things. An item as small as 10 millimeters. to as big as 1 meter. Now they've got smaller little boats that can go out, little floatable systems to collect surface waste. They've got cranes to pick up bigger ones. They've got conveyor belts. I mean, all of this is pretty incredible. And to give you sort of some sense of it, the size of this ship, it's almost, if you put it in height of a building, it's almost a 19-story building tall. And if you laid that building down, it would be about 17 stories long from front to back. So you can see they can get a lot done on there. Still, I was thinking, when you have to keep heading back to shore and taking all the plastic and stuff with you, they can sort it and package it so tight, and they actually have something on board to process it. Some of the plastics they can change into electricity and actually use it to power things on the boat and the sorters and all of that kind of thing. So it's sort of ingenious and
it is
logical, and you know what I mean? You're one of those things like, why hasn't anyone done that or thought of that before? So when it is up and running, they're going to start at some of the most polluted river mouths, deltas out in Southeast Asia is the idea.
So it's not out on the water yet.
It's not. It's in development. They hope to start construction next year, and they're going to launch it in 2024. I mean, there's a lot to be done still, but there's so many firms working together on this, getting the technology going, getting everything set up, so many contributors donating, that kind of thing. It sounds like they're very much on track for their plans.
Well, and you're absolutely right. There's some 20 different companies and even a number of research laboratories. So there's scientists. You know, this isn't just, something on a whim. This endeavor is science-based. And I was intrigued, as you mentioned, that they're going to be doing the sorting on this. There's two main collection systems. One is the conveyor belt, and then the other is the floatable collection system that actually goes away from the vessel, if you will. And the fact that they're generating also their own power on this. If you look at some of the images, just the solar capacity really is amazing.
And it can process things 20 hours a day, 7 days a week. I mean, those are some pretty impressive work hours. That's a lot to get done. So, depending on the waste, where it is, about 1 to 3 tons of waste per hour. That's huge.
That is
so
huge.
Of course, it's a huge problem.
Well, I was going to say, it's huge, and it's still not enough. Right, because they estimate it's like 8 million tons of plastic waste end up in the oceans every year, and some scientists or mathematicians figured out it's equivalent to 5 garbage bags for every square foot of coastal beach around the world. I mean, that's how much is out every year, and just the premise of plastic, and we've talked about this before, that the lifespan of the use of plastic, whether it's a plastic bag or a toy or what have you, it could literally be measured in hours or a few days, but the impact on the environment is for centuries. And I wanted just to point out very quickly, we actually did a full episode on our podcast at bigbluemarble.earth, episode 9, called Waves of Plastic, Our Oceans Are Drowning. And we interviewed George Leonard, the chief scientist of the Ocean Conservancy. I encourage our viewers to give that a listen. Really amazing, the scientific background and what's going on in our oceans. Again, that's episode 9. Just want to get that plug in because it really was a great episode.
And about this ship too, it's also going to be used as scientific missions. So scientists are going to go on board. They're going to be able to study a lot of these things while they're there. And when it's in port, it'll be used for educational and learning conferences. And of course, you can see it's a pretty impressive ship. So they're also going to use it sort of as a talking point like this, as an ambassador for the ocean, to get people to pay attention, to stop using so much plastic, that kind of thing. So it's a very multifaceted project.
This is great, Christina. We look forward to an update on that as we get closer to the launch. And I would assume they're going to do some sort of live stream as well on it. So we look forward to following that story.
Definitely.
Well, thank you so much. We appreciate your time, and we look forward to connecting with you on the next episode, Christina. Have a great day.
Bye-bye.
And as we wrap up, if you like what you're seeing, we ask you to support what we're doing. Please give us a thumbs up, like, and subscribe to this channel. The whole goal is to inspire and inform people, to propel the action that's needed to save our planet. We want to thank you for your time today. Stay safe and be well, and we look forward to having your company on the next edition of the Blue Files.